Hi, my name is Atul. I am from Kerala. I am here to take some portions of physical geography. Fine. Now, before that, you want to know a very important thing, and I hope you know that how the earth gets its heat. It is not by the direct solar insolation, because direct solar insolation, it is a short wave radiation, and that short wave radiation, the earth's atmosphere is not able to absorb that short wave radiation. So the earth gets heated by the long wave radiation, which is absorbed by the short wave radiation by the ground, and that will release, it will reflect back, and that reflection is said to be the terrestrial radiation. So the earth gets heated by the terrestrial radiation itself. So what is the source basically? Suppose this is the ground region and this is the sun. So the source is said to be so sun is not a direct source. It is responsible for the heating of the land. Basically it is the land, because it will reflect back the long wave. So short wave radiation coming, so this is long wave radiation. From this long wave radiation, the earth's heat, not from the sun. Fine? Because there is nothing to absorb the short wave radiation. But long wave radiation can be easily absorbed by the atmosphere. Getting it right? Yes. Now this is the source. Okay. Now that's why when we are moving upward through the troposphere, we are moving away from the source. So that's why when we move upward through troposphere, the temperature decreases. Fine. So that's why you can find in the top of the hills and all, you feel some cool. So you have a doubt that why the sun is, we are near to the sun, but still we are feeling a chillness. The reason is this thing, the sun is being, so the earth is being heated by the terrestrial radiation. So we are moving away from the source. Right? Now, the second layer is, then why it is called tropopause? After troposphere, we have tropopause. Why? See, what is happening? Suddenly, gradually temperature decreasing. So there is a point where there is no change in temperature. It just stuck out. Okay? So there is no, so the temperature change has been paused in the, after the troposphere region. So that way is called as tropopause. Now, one more thing, I hope you know that why the tropopause in the equatorial region is about 16 to 18 kilometers. It varies according to the formation of ITCZ and all. And in polar region, it is about 7 to 8 kilometers. Now, what is the top? So the temperature at the top of the tropopause is lesser than the temperature at the polar region. Why? See, basically this is polar region, so when we move upward, this should be a region where it should experience a very low temperature. But the reverse condition happened. Why? We are experiencing more lesser temperature condition in the equator. Why? Because have you heard about the adiabatic lapse rate? Okay, so that's the reason. So we'll discuss it, don't worry about it. Okay, yes. Now stratosphere. So suddenly temperature decreases in when we go up to troposphere. Now what happens in stratosphere? In stratosphere, when we move upward, the temperature suddenly start to increase. Why? Because of the presence of ozone layer. So ozone layer has the ability to absorb the sun's short wave radiation. Okay, so that's why when we move upward, what happened? Temperature suddenly start to increase. Now in the mesosphere region, now we have stratopause, and then suddenly we have a constant temperature, so stratopause. Then we have the mesosphere. What happened in mesosphere? There is nothing to absorb anything, neither a gases, okay, nor ions, nothing. So that's why again when we move to the mesosphere, again gradual temperature decreases. See, if we have to experience any kind of heat, there should be something to absorb in the atmosphere. So that's why you can't find any kind of gradual temperature increase in the mesosphere. And after that you can see it gradually increase, because there we can find the presence of ions, thermally induced ions. In ionosphere also we have different ions which will absorb the heat energy. So that's why again gradually start to increase. So thermosphere is a region where you can find more number of heat compared to the exospheres and all. So that's why it's called thermosphere. So this is the basic division of the layers of the atmosphere. Fine? Yes. Then we learned about the very important topic called the pressure belts. Okay, and before that I will give you a small idea that what is the reason of the movement of wind, or why when the air moves, what's the reason behind the movement of the air. Why? Because we know that the particular term is called pressure gradient. Okay, suppose this is a plank or whatever, a road, and I am keeping an object here. Okay, if the object has to move, I have to give an external force. That's what the first law of motion states. Or else, if I want to move this object without any force, I should change the potential. So when I change the potential, the object will move from higher potential to lower potential. That results in a movement. In the same way, if air has to move, there should be a change in gradient, and that gradient is called the pressure gradient. So the air will always move from the higher pressure region to the lower pressure region. Now, how the pressure condition is being changed? Due to the application of temperature. So when the temperature increases, the pressure, there it creates, see basically this what you have to keep in mind, it is not a relation. Okay, we used to study the Gay-Lussac law, right? In Gay-Lussac law we learned when the temperature increases, pressure also increases. So that is at a constant volume. So that is a microscopic concept. So it is a relationship. But here it is not speaking about any kind of inverse or direct relationship. Here what is happening is, due to the increase in temperature, that particular region experiences a low pressure. Why? When temperature increases, the gases start to expand, and when the gases start to expand, it started to move upward. So when I take my hand upward, what will happen? The pressure get reduces. The same way, when temperature increases in a particular region, the air start to expand, and then it start to move upward. That result in the formation of low pressure. So you should not keep in mind that when the temperature increases, pressure decreases. No, it is not a relationship. It is a condition that you have to see it. Fine, the relationship, that is a theory perspective, you don't think about it. So whenever increase in heat, at that particular region the air get expand, it will lift out, which result in condition of low pressure region. That's it. And now when the air get cooled, what will happen? When the air get cooled, it increases, it gain its weight, it will start to sediment or settle down, and when it start to settle down, see this is a packet of air, it is settled down in my hand. So now my hand is experiencing a high pressure, so that region become a high pressure region. So this thing you have to keep in mind in the entire climatology. So this is the basic of the climatology. So this geography, as I said, is also related to some kind of physics also. A very simple thing. Clear? Yes. So now, so the pressure belts. So what are the different pressure belts? And I hope you know there are two different kind of pressure belts. One, the thermally induced pressure belt, okay, which is influenced by the direct application of sun. And then we have the dynamically induced pressure belt. In thermally induced pressure belt, we have the equatorial low pressure belt. Why equator has the low pressure region? Due to the high solar insolation, the direct insolation result in the heating of this region. And when there is a heating of this region, what will happen? That region will automatically become a low pressure zone. Okay. Then what about the polar region? Since it is a very low temperature, that will result in the formation of settling of certain air packets. So that's why this will be a polar high pressure zone. Fine. Now what will happen? See, since the air get expanded, it will move upward. So here we have the high pressure zone in the upper tropospheric region, and what will happen? There the air will diverge, and ultimately it is moving into the colder region, and what will happen? It will settle down. Fine. Okay, and this will create a high pressure zone. So this is the subtropical high pressure zone. And now what will happen? So this is high pressure region, this is low pressure region, and now the wind will move from high pressure to low pressure. Fine. So that's why high pressure to low pressure. Now due to the Coriolis force, it will have a clockwise movement. Okay, and we know the effect of Coriolis force will be 90 degree. Yeah. Deflection, that is clockwise direction in the northern hemisphere and anti-clockwise direction in the southern hemisphere. And I hope you know the reason. Don't look in this perspective of globe. You have to look the upper view. If you see the upper view, the west to east movement of earth, then you will get it. Okay, because in the last class I showed it properly. I had discussed with the globe and all. Okay, yes. So that's why now actually the air has to move like this, but due to the Coriolis force, it will have a clockwise deflection. Okay, and similarly here also, it will have a clockwise deflection. And now see, the both wind is converging that region, so that's why it is called, this region is called ITCZ, intertropical convergence zones or doldrums, where you can find the area of calm region. And this wind, so it is starting from the eastern side, so it is called easterly. Fine. Or it is called trade winds. Why trade winds? Because these winds help the older vessels or older traveler to move from one region for the trade activity. So that way it is called the trade winds. Clear? Yes. Now you can see a cycle is formed, and this cycle is called, very good, it's called Hartley cell. This is called Hartley cell, and this is the dynamically induced pressure belt. Okay, due to the formation of low pressure belt in the equatorial region, it results in the formation of dynamically induced pressure belt. Getting it right? Yes, very good. Now, again you can find divergence. Some air moved here, some wind is moving in this region. And now we have, here also we have the divergence. So now the wind is coming, the colder wind is coming from the pole, and comparatively hotter wind is coming from the equator or the subtropical region. So what will happen here? What will happen here? The warm air which is coming from the subtropical region, it will be forcefully uplifted, and that result in the formation of front. Very good, very good. So here you can see there is a upliftment of warm air, which result in the formation of front, and here air is uplifting, this region will become a subpolar low pressure region. And again the cycle completes. So here you can see high pressure, again it will move in this side. So this is what, so here you can see the wind, now the wind will move from high pressure to low pressure, and due to the Coriolis force it is diverting into clockwise direction. Since it's starting from the west side, this region is called the westerlies, and this latitude is called, you remember, host latitude. Why it is called host latitude? Because there is a region where it's where you can't find any kind of wave, because there you can find the divergence is there. So in that region, when the traveler used to travel from one region to another, they used to throw their horses through the sea. Why? Because so that the weight get reduced and the vessel can move. So that's why it is called the host latitude. So that's what the idea, that how you have to think it. Okay. So here also there is cell has been completed, and this is called, very good, this is called Ferrel cell. And here you can find another cell which is called the polar cell. So here we have, so this is high pressure zone, low pressure zone. So here you can find the movement of the presence of easterlies, polar easterlies. Okay. So these are the thing about the pressure belts, and this is a very, very important topic that you all have to note it down. Fine. So this is what, so this is the tropical zone, then come the temperate zone. And what specialty of temperate zone? The climatic condition there is very, very complex due to the dynamically induced formation of dynamically induced pressure belts. And then we learned about the front, right? Okay, how the front is born, how the cold air mass, the continental air mass and the maritime air mass are formed, and the junction between two air mass of different temperature is said to be front. So what is cold front? In cold front, the colder air mass will move faster compared to the warmer air mass, which result in the sudden upliftment of warmer air mass, which result in the cumulonimbus cloud, which also result in the formation of heavy rainfall. And what is warm front? Here warm air mass will be moving faster compared to the cooler air mass, but here also what will get uplifted? The warm air mass will get uplifted, and what will happen? That result in the formation of drizzles, a very small rainfall in the temperate region. And I hope I also discuss about the extratropical or temperate cyclones, okay, how it is being formed, how the low pressure condition is being formed in the extratropical cyclones, and we can't find any kind of formation of eye in the extratropical cyclone. And the movement of extratropical cyclone is always from west to east. And the extratropical cyclone always occurs in the land area, not in the water area or the ocean area. So when it enter into the water area, the energy get loosed and it will stop. So that's why you have to keep in mind Why the cyclonic and rainfall mitigation in the advanced country is said to be more advanced? Because these disasters are predictable, unlike the tropical region. So never ever compare with the mitigation system of the mitigation system of India with respect to the temperate region, because the mitigation system or if you see the cyclone, if you see the flood situation in the tropical, every country in tropical region is very, very dangerous and unpredictable. Okay, so never ever compare our climatic condition with Europe or the other north countries. It's very different. Okay, yes. Now after that we learned about the tropical cyclones. How the tropical cyclones are formed? It starts its source from the water area, water bodies. Low pressure condition will happen due to the excess heat in a tropical region. Then what will happen? Air will come from the high pressure region. Due to Coriolis force, it will form a cumulonimbus cloud and formation of eye that result in the formation of tropical cyclone with a very heavy rainfall. Now, the movement of tropical cyclone always from the east to west, just opposite to that of the temperate cyclone. And the tropical cyclone, it starts its origin from the sea and it's lost when it get into the land area, because it doesn't have any moisture, fuel to carry the moisture, and that will end the cyclone, and which is very, very unpredictable and very dangerous also. You can see the speed of temperate cyclone, it varies from 50 to 60, at most 70. But if you see in the case of tropical cyclone, you can find the 120, more than that, 240 till you can find it, and it is very, very devastating. Okay, you can enjoy your holidays in the temperate region, okay, but you will enjoy your death in the tropical region. So that's what the difference is all about. Okay, yes. So that's all about the cyclone. Then I think that's it, right, in the climatology part. Yes, we learned about thunderstorm. One more thing, the very, very important thing, the El Nino, La Nina. Okay, we also learned about a cycle called Walker circulation. What is happening in the West Pacific region? Okay, what is happening with the West Pacific region? What's the reason behind the formation of in normal condition? What happens, guys? In normal condition, suppose this is the Peru region and this is the Australian region. Okay, clear? So due to the trade winds, what will happen? Due to the formation of trade winds, due to the presence of trade winds, the warm water from the tropical region, it will move towards the Australian region, and that will create a condition of low pressure. And when the warm water is, when the trade wind is moving to the surface of this particular West Pacific region, what will happen? There will be a process called downwelling. That is, when the surface water moves, in order to fill that vacuum, cold water from the deep of the ocean will start to move upward. So when there is a cold water, that will create a formation of high pressure zone. And also we have a very famous Peruvian current or Humboldt current in that particular region. So that is more than enough to create a high pressure zone in this region. Now, high pressure to low pressure, wind is moving, it is lifting. So this cycle is called Walker circulation. So this is what happened in normal year. So low pressure condition Australian region, then we have the mascarene height here, which is high pressure region. So this is India, and here we have low pressure region. Okay, so low pressure, high pressure in the tropospheric region, the wind will move from high pressure to low pressure, and it will intensify the low pressure condition, and this will intensify the monsoon situation, forming an Indian Ocean dipole, high pressure, low pressure. So this is the best condition for the rainfall. But what happened during El Nino condition? The trade wind will become weakened, and when the trade wind will become weakened, accordingly due to the influence of westerlies, the warm water will transfer to the Peruvian region. And when the warm water start to transfer to Peruvian region, this will become a low pressure condition. This will become a high pressure condition. So there is no dipole formation. So you can find a drought situation, less intensification of low pressure, and that will weaken the monsoon. So this is what happened in the El Nino condition. And what is La Nina? La Nina means intensification of Walker circulation. That is, westerly become weakened, trade wind will become more stronger, that will intensify the low pressure here, and that also intensify the monsoon. That happened. That's why you remember about the flood in the South Indian region in the 2017-18. That is said to be the La Nina condition, because the trade wind get intensified, result in the intensification of Walker circulation. Okay, so this is all about the climatology session. I hope I completed everything, nothing to be missed out, right? Okay, and please do locate certain places, the climatic regions, etc., which is very, very important. And then we also have some biogeography, like the different climatic region. One more thing, why you can find the desert, tropical desert in the western side? The reason? Very good, very good. One, due to the offshore trade wind. Second, due to the formation of cold current. So whenever cold current, the area, that region will be very, very cooler. That will have no convection cells, no convection that, and no rainfall. So whenever you can find warm current, that will intensify the convection, result in the rainfall. So these are things that you have to keep in mind. Clear? So two conditions. Clear? Yes. And different climatic conditions. So you have the Laurasian type, China type, that east margin, west margin, etc. So that you have to keep in mind the different vegetations, everything, and that will be taken in detail in the ecology session. Okay. Then we have the oceanography, a very, very interesting and very simple part of the entire physical geography. In oceanography, we learned about the two movements of water. One, we have the vertical movement, then we have the horizontal movement. In vertical movement, we learned about the wave formation and then the current formation. Now, what do you mean by wave? I hope you know wave. So basically, the movement of particles in a wave is not in a wavy form, it is a circular form. So when we go downward, we can find a very less influence of waves. Okay, so that's why the wave will be more in the surface region due to the application of wind, and the gravitation will be more according to that. Okay, then what is current and what are the driving force behind the formation of current? One, we have the formation of winds, the planetary winds. Second, the Coriolis force. Third, the gravity. And then we have the solar insolation. So these are the things that is responsible for the formation of currents. And I hope you know from where the warm current starts. The warm current starts from the tropical region. Since there is direct application, it will move towards the cold region through the surface level. Then what about the cold current? It will move from polar region to tropical region through subsurface level, since the water is heavy and it will move downward. That's the one reason. Then how the salinity will affect it? We know the higher saline water will move to the lower saline water and vice versa. And I hope the salinity is more in the polar region. Why? Because since the presence of iceberg, how iceberg is formed? By the extracting the pure water. Okay, when the pure water is extracted, the leftover will be the salty kind of thing. So that will increase the saline nature. And if you see the tropical region, due to heavy rainfall, the saline character will be less. And also you can find a discharge of different water, different rivers. That will decrease the salinity, and that will decrease density. And that's how the it will trigger the movement of currents. Okay, then we discuss about the different characters of current. When both the current it coincide with each other, that will be a very good fishing ground, and you can find a very foggy nature. Then we discuss about the different kind of gyre, North Atlantic gyre, that result in the formation of very mysterious sea called Sargasso Sea, which created the growth of Sargasso, a algae in the center of the sea, where the water is very calm and the movement of ship is being prohibited at that region. Okay, fine. And also I just discussed about have you heard about the Atlantic meridional overturn circulation, that how the Gulf Stream, the weakening of Gulf Stream will affect the Indian Ocean region also. Why? When the Gulf Stream weaken, what will happen? In order to maintain the heat, the warm current will try to pass through the Atlantic region. That will make the Indian Ocean region cooler, and that will restrict the formation of rainfall. And when the Gulf Stream will become stronger, the reverse happens, so that will result in the heavy rainfall. So that's how the AMOC works. Okay, and the different currents of the world, you have to know it. The region also, the Grand Bank, Bahia Blanca, and in the Japanese coast, you have in the Kuril Island, you have the formation of combination of warm current, the Kuroshio and Oashio current. Then certain currents like Canary current in California current, which result in the formation of desert effect of Mojave and Sonoran in the western part of North America. Okay, then we have the Canary current, which result in the formation of Sahara. Then we have the Benguela current, which result in the formation of Namib desert. Then we have the Falkland current, the Falkland Island, which results in the formation of Patagonia Desert. Then we have the Humboldt or the Peruvian current, which results in the formation of Atacama Desert. Then the Great Australian current results in the formation of Great Australian Desert. So these are the things which you have to keep in mind with respect to the warm current. Then that's all about the horizontal movement. Then we have the vertical movement. In vertical movement, we have the formation of tides and then the downwelling and upwelling. So how the tides are formed? Basically, it is due to the gravitational force of attraction between Sun, Earth, and Moon. And there are two type of position. You know, remember it. One, the Syzygy position, where the Sun, Moon, and Earth are aligned. From where you can find the extra pull and push, which result in the high tide condition more as compared to the other day. Then we have the quadrature position, where the Earth, Sun, and Moon is in 90 degree, which will have lesser high tide and lesser low tide as compared to the normal condition. That is which result in the formation of spring and neap tide. So Syzygy position S, spring. Okay, so Syzygy position responsible for spring tide and quadrature position responsible for the neap tide. Then we have a formation of ebb and flow. What do you mean by ebb? What do you mean by flow? And how it helps in the harbor formations and all. Okay, so these are the things you have to keep in mind with respect to the tides and how the tides are formed, etc. Then we have the upwelling and downwelling, and I hope you know the Ekman transport, not in detail, it is not at all necessary for you, but still how the upwelling and downwelling works. Okay, what is Ekman transport? You can see in polar region, you can't, or if you travel through sea, our vessel will never move in the direction of the wind. It will divert 45 degree, and it is due to the Coriolis force, because there the wind and Coriolis force are two vectors, and we will always move in the resultant region, and that was discovered by Ekman. So that's what is called Ekman transport. So that's how you can see the formation of upwelling and downwelling. Now, upwelling will create a situation of a good fishing ground, and downwelling will create a good fishing ground, and upwelling will result in the formation of the hot kind of things and all. Okay, so these are the things that you have to keep in mind. Okay, any doubt? So that's all about the horizontal movement. Okay, and that's all about the oceanography. Okay, so we